Hello, and welcome to the channel. Look around you, at the phone in your hand, the satellite that brings you this video, or the compact nuclear medicine that saves lives. All of it was, at one time, science fiction. The line between impossible and inevitable is constantly being redrawn, usually right after someone says, "That'll never work." Today we're going on a journey to the absolute edge of that line. We're diving into a thought experiment, a conceptual design that pushes physics to its breaking point. But here's the crucial part. Every technology we discuss, from compact fusion to quantum communication, is actively being researched in labs around the world right now. No chalkboards required, just audacious engineering. This is a blueprint for what could be a reality tomorrow. This is the story of the Nautilus X, a conceptual submersible designed to achieve the unachievable. We're talking full ocean depth, hypersonic speed, and absolute signature dominance, all driven by integrated artificial intelligence. Yes, it's an overachiever. The Nautilus X isn't an upgrade. It's a total reimagining. Its design mandate is to achieve absolute operational superiority across every critical domain, rendering today's naval platforms functionally obsolete. Think from flip phone to smartphone, but underwater and mildly terrifying. This is engineering driven by revolutionary capacity, not conventional metrics. The goals set for the Nautilus X are staggering: full ocean depth, EFOD, a sustained operational depth of 11,000 meters. This is the deepest part of the ocean, the Challenger Deep, subjecting the hull to pressures exceeding 1,100 bar, 75 times the pressure a standard military submarine experiences. Hypersonic submerged speed, HSS, sustained velocity exceeding 150 knots underwater. To put that in perspective, a modern attack submarine is lucky to hit 30 knots. This vessel will move faster than most torpedoes, and some Wi-Fi. Absolute signature dominance, ASD, near zero detectability across every spectrum, acoustic, magnetic, and thermal. Achieving these three simultaneous, conflicting goals requires us to embrace technologies currently confined to advanced R&D. We must move beyond passive improvements and into a future where fiction becomes non-fiction. At 11,000 meters, the margin for error is zero. The pressure is so immense that any microfracture will lead to immediate catastrophic implosion. Margin for error somewhere between zero and nope. To survive this, the Nautilus X adopts a heterogeneous hull strategy. The primary pressure hull must be crafted from high-grade, deep-sea titanium alloys, chosen for its superior strength-to-weight ratio and its inherent non-ferromagnetic properties, which passively aid stealth. But titanium alone isn't enough. We must integrate highly optimized structural segments using ceramic spheres and complex shapes. Ceramics offer significantly higher compressive strength, crucial for minimizing weight while maximizing crush resistance. Joining these dissimilar materials, ductile metal and brittle ceramic, is one of the most challenging engineering problems of the design. Furthermore, the construction process is an integrity imperative. Every primary pressure hull section is joined using electron beam welding, EBW, a hyper-precise, vacuum-based method essential for preserving the metallurgical properties of these advanced alloys under extreme stress. Think of it as surgery with lightning. And who ensures this flawless construction? It's the AI. The AI-driven quality assurance system utilizes multi-sensor monitoring, to check every weld and component against the generative design model, ensuring zero defects before the vessel ever touches the water. To achieve its goals, the Nautilus X needs an energy source far beyond fission. Coffee won't cut it. The answer is a compact fusion reactor, basically a tiny star with better manners. Fusion power grants practically unlimited endurance, bathroom breaks not included. That steady torrent fuels a revolutionary dual-mode propulsion system. At 300 knots, the vessel covers nearly 150 meters every second. Any necessary stability correction, like adjusting the gas injection to maintain the supercavitation bubble, requires an operational loop far faster than human reaction time. Human intervention at these speeds and depths is simply impossible. The AI is the central nervous system of the Nautilus X. It's the generative AI that initially designed the hull for both low drag and supercavitation stability. But during operation, it serves as the autonomous mission planner and definitive safety mechanism. It's processing real-time pressure gradients, fluid dynamics, and stress analysis, creating a constantly updated digital twin of the vessel. The AI's motto, measure twice, don't implode once. Should an unforeseen structural stress approach critical limits at 11,000 meters, the AI is authorized to override human command and initiate immediate emergency procedures. The most complex challenge is absolute signature dominance, ASD. The silent MHD drive generates a huge magnetic field, making the vessel instantly vulnerable to sensitive magnetic anomaly detection, MAD systems, often carried by helicopters. The solution is an active degaussing system powered by the fusion core. This AI-controlled cancellation system constantly generates an opposing magnetic field tuned precisely to negate the total magnetic flux emanating from the vessel. Stealth is no longer a passive trait. It's a high-power, dynamic function maintained by the AI and the unlimited energy of the fusion core. Finally, to communicate the massive amounts of data generated by the AI without compromising stealth, the Nautilus X needs a breakthrough, a deep-sea quantum communication link. By transmitting high-bandwidth data using the blue-green optical window of seawater, the vessel can maintain a secure, high-speed cognitive link to strategic command without ever having to surface or risk acoustic detection. The Nautilus X is a conceptual triumph, a synergistic blend of AI, fusion power, and supercavitating hydrodynamics. It simultaneously achieves speeds and depths previously considered impossible, pushing science into the future by turning what we called science fiction into a blueprint for nonfiction. Science fiction called "We're Borrowing Its Furniture." The constraints are immense. Scaling a compact fusion reactor, achieving a zero-defect heterogeneous hull, and validating the trust required for autonomous AI control in a zero-tolerance environment. Solve these, and we don't just build a new submarine. We unlock a new playbook for undersea operations, complete with fewer heart attacks. The future of technology isn't about small steps. It's about revolutionary leaps engineered by the human mind and executed by artificial intelligence. We bring the audacity. AI brings the coffee and calculations. Outro. Thank you for watching. Don't forget to subscribe and let us know your thoughts on the Nautilus X in the comments. If you laughed at least once, that's mission success. See you on the next deep dive.